Uh, Good morning, students. I welcome you all to Bihar Mumbai Municipal Corporation Education Department Online Education for English Medium session for Class 10, Subject Science and Technology Part 1, and the chapter which we are discussing and the subtopic which we are going to learn today is Moon and Mars mission and Mars mission that we are going to learn today. My name is Ms. Bushra Maksud. Okay, so student. So, uh, which chapter we are learning? Lesson number 10, that is space mission. Till here, students, what we have learned much more things about what different types of orbits. Number first one was what higher Earth orbit. Second one was middle Earth orbit, and the last one was lower Earth orbit. Everything why the on the basis of the functions of the satellite, why they are placed in which orbit, that everything we have discussed in this chapter. So students, before going to today's topic, that is Mars and Moon mission, we will revise some topic which we have discussed in the last lecture. Last lectures we have learned about the launch vehicle, right? Launch vehicle are vehicle due to help of this launcher, the satellite is been launched into the Earth orbit or it is launched in the outer space. See, what was satellite launch vehicles? Satellite launch vehicles are used to place the satellite in their specific orbit. What was the main function, students, for this launch vehicle? The satellites are used to place the satellite into a specific orbit. Number second, the functioning of the satellite or launch vehicle is based on which law? Newton's third law of motion. This function was based on which, students? Newton's third law of motion, that is every action has its equal and opposite reaction. The launch vehicle use specific types of fuels. What, students? They are use specific types of fuels, and after that the gas produced due to the combustion of the fuel expand due to its high temperature and it's expelled forcefully through the nozzles at the rear end of the launch vehicle. How this was done in detail we have seen, right? Today we are doing just a revision. So students, the fuel which is in the launch vehicle, after combustion, what happens, students? After combustion, the gas has been produced, it has been expanded at high temperature and it has been given out forcefully from the nozzle of the rear side of the launch vehicle. Hence, that it is given out forcefully from the rear side of the launch vehicle. The upper part got a thrust, right? As a reaction of this, what will come, student? Thrust will act on that vehicle, which drives the vehicle high in the space. What it will do? It will drive that vehicle high into the space. Hence, we have termed that the launching of a satellite is based on Newton's third law of motion. That is, every action has its equal and opposite reaction. The structure of the launch vehicle is decided by the weight of the satellite and the type of the satellite orbit. Okay, students? See the structure on weight. The structure of launch vehicle is decided by what? It is decided by the weight of that satellite and in which type of the orbit that satellite is supposed to be launched. It is depend upon that. The fuel of the vehicle also depends on this factor. The fuel which is used in this launcher vehicle, it is also depend on these factors. The fuel forms a major portion of the total weight of the launch vehicle. Thus, the vehicle has to carry a large weight of the fuel with it. Okay, students? See, as we know that what? The fuel, it consists of the major part. So, there is a high amount of weight is there this launcher has to carry. So for that reason, to overcome this problem, launcher vehicles with more than one stages are used, right? To overcome, as it was consist of the fuel which was having very high weight, and it was very hard to carry the whole fuel till the end. For that reason, to overcome this problem, student, what this launcher vehicle, they are made up of several stages, more than one stages. Due to this, the weight of the vehicles can be reduced step by step after it launching. Okay, so at the launching process starts, so step by step the weight of the vehicle is reduced and it is easy to boost the speed of that launcher vehicle. For example, consider a launch vehicle having two stages. Now, see, to understand this concept, let us consider that, have an example that consider a launch vehicle having how much stages? Two stages. For launching the vehicle, the fuel and the engine in the first stage are used, right? For launching the vehicle, the fuel and the engine in the first stage are used. This impart a specific velocity to the vehicle and take it to the certain height. After which we have what, when the first engine is used, the fuel of the first engine is used, what it will impart? It will impart some velocity to that vehicle, and after that it is gone to the certain heights. Now once the fuel in the first stage is exhausted, now after the just giving it some height, after having some specific velocity, the fuel in the first stage is now exhausted. The empty fuel tank and the engine are detached from the main body of the vehicle and fall either into a sea or an unpopulated land. See, as the fuel in the first stage exhausted, so the empty tanks, empty fuel tanks, and the engine in the first stage, which was there, what it after that, what it get detached from the main body of that vehicle and it fall either into a sea or on a unpopulated land. As the fuel in the first stage is exhausted, the fuel in the second stage is ignited. Now, as see students, after the first stage, the fuel which is there in the first stage, it is being used to give him some specific velocity and to take that launcher vehicle to certain height. So after finish of the first stage, what second stage has got ignited. However, the vehicle now contains only one, that is the second stage. The weight now been reduced, obviously when the first stage is been detached, so obviously the weight will get reduced. The vehicle can move with the highest speed. Now vehicle can move with a higher speed. Almost all vehicles are made up of either two or more stages. See, all the launcher vehicles, it is made up of two or more stages. Always to what? To reduce the weight of the launcher satellite. For that purpose and to give easily can give a higher specific heat and to give a specific height to that launcher vehicle for that purpose. As an example, the structure of Polar Satellite Launch Vehicle, that is PSLV, developed by ISRO of India. See, for that purpose, students, the structure of what PSLV is developed by ISRO of India. The launch vehicles are costly. The launch vehicles are costly because they are being used only once. They are used only for one's purpose. For that reason, students, the launch vehicles are very costly. To overcome this, USA has therefore developed a space shuttle. See, students, see the launcher vehicles which are used. They are what, students? They are for using for one purpose only. So to overcome this, what USA has developed a space shuttle which can be reused multiple times, which return to the earth except from the fuel tank and can be reused in multiple launches. Now see here in the photograph of PSLV which is made by ISRO. Here see they have shown as the 4 stages of PSLV. The lower one, can you see the rocket type structure, student? That is nothing but what? It is a engine using solid fuel. What it is, students? It is the engine using solid fuel which provide the initial thrust. And initially, this fuel is being burned, and after completion of this fuel, student, this which solid fuel is used, and it gives initial thrust to this engine. Now, first stage. See, in the first stage, which fuel is used? Solid fuel is used. If it is of 2 stages, then in second stage, which fuel is used? Liquid fuel. In third stage, again solid fuel, and fourth stage, liquid fuel. Like this, students, solid, liquid fuels are used in various stages of this launch vehicle. And can you see the upper part, the conical one? That is nothing but a place for satellite. In this place, the satellite is being kept for launching. Okay. So this is the structure of a launch vehicle, that is PSLV, and how it is working, how the different stages are working. This all we have learned, and on which law it is based, the working of this, that is Newton's third law of motion, that is every action has its equal and opposite reaction. Now, as we have seen the working of this PSLV, now we are going to see how space shuttle is being used. Can you see a jet-like structure here in the corner? That is nothing but a space shuttle. Now see how when space shuttle is launched, see there is a separation of the booster rocket. When the fuel of this booster rocket is finished out, there is a separation of this booster rocket. After that, when the fuel tank is finished, so the separation of fuel tank is used. This tank is get separated from space shuttle. Then this space shuttle, from this space shuttle, the satellite comes out, and this satellite start revolving around the orbit of the Earth. And after just placing this satellite into the orbit of the Earth, this space shuttle comes back to the Earth. See, satellite is launched in its orbit, and space shuttle returns to the Earth back for its multiple use. For next launching also, then the same space shuttle will be used. So see, students, with the help of this space shuttle, the cost for some missions is get reduced, because one thing only, the space shuttle is been used multiple times, but we have seen in a PSLV and GSLV, it is used for only once. It is not used for multiple purposes. So I hope these two things you have understood. Now, see, students, we have seen that space mission away from the Earth. When satellite are planes beyond the Earth's gravitational force, means beyond the Earth's orbit. So he has to overcome a velocity, and we have to give some minimum velocity, that is escape velocity, we tell it, so that the satellite can go to the outer space beyond the Earth's gravitational force, and we can do the observation in the solar system or even out of the solar system. So how to calculate this minimum escape velocity? This formula we have seen here. See, escape velocity on a planet, that is VESC, equals to under root of 2 gm upon r. Now what is capital G, student? That is gravitational constant, and its value is 6.67 into 10 raised to minus 11 Newton meter square per kg square. Capital M is the mass of the planet, equals to 6 into 10 raised to 24 kg. R is the radius of the planet, that is 6.4 into 10 raised to 6 meter. By keeping all this value into the formula, students, what we get? We get the escape velocity is 11.18 kilometer per second. That is 11.2 kilometer per second. So the spacecraft escape the Earth's gravitational force to travel to the outer space. It must have minimum velocity of 11.2 kilometer per second. So this was all, students, revision of the previous sessions which I have taken. I hope you all have understood all the points. Now we are going to see the very interesting topic which I'm going to teach you today. That is moon mission, Mars mission. Okay. See, moon mission. Can you see the American flag on moon surface? Right. A satellite is also there. See, on a moon surface. Right. So this is what the America was the first country to land on the moon. Right. On the surface of the moon. So, see, student, what was that? We are going to see how this mission was taken place, who has done it, everything. See, since the moon is the closest astronomical object to us, we know that it is very closest astronomical object to us as compared to the other objects. The first space mission to object in the solar system were the mission of moon. The first mission which was taken place on the Earth was what, student? It was a moon mission. Such missions have so far been executed by USA. USA States of America. Soviet Union, European country, China, Japan, and India. See, all these countries has executed such moon mission, which were that country: USA, Soviet Union, European countries, then China, Japan, and India. The spacecraft in the lunar series sent by the Soviet Union reaches near the moon. What is this lunar series, students? See, the spacecraft in the lunar series. Lunar series means it is a series of robotic spacecraft which was sent by the Soviet Union on a moon surface. Okay. So see, the series of from the lunar series, Lunar 2, which was launched in 1959, was first such craft. After that, till 1975, 15 spacecraft made chemical analysis of the moon and also measured its gravity, density, and radiation. Now see, Lunar 2 was launched in 1959. That was the first aircraft which was launched there. And after till 1975, how many spacecraft were launched? That is 15 spacecraft made a chemical analysis of a moon and also measured its gravity, density, and radiation. Last 4 crafts even landed on the moon and brought the sample of the stones on the moon for analysis in the laboratory. See, last 4 spacecraft of the lunar series, what they have done, they have landed on the moon and got what? The sample of the stones on the moon and analysis on a laboratory. All these missions were unmanned. These missions were unmanned means in this spacecraft, no man was there. Only the satellite with the instrument was there. The collection was also done by the instrument. No man was there. This mission was an unmanned mission. Okay. After that, American also executed moon mission from 1962 to 1972. From 1962 to 72, students, American also executed such moon missions. Okay. The specialty of these missions was that some of these were manned missions. Okay. You see, well, they have executed some moon missions from 1962 to 72, means totally 1 decade. And some of them were manned missions, means astronaut was sent in a spacecraft, in a satellite on that moon mission. Hence, it was a manned mission. In July 1969, Neil Armstrong became the first human to step on the moon. In 1969, who was the first scientist to step on the moon? That is Neil Armstrong, became the first human to step on the moon. In 2008, Indian Space Research Organization, that is ISRO, successfully launched Chandrayaan-1 and placed it into an orbit around the moon. See, in 2008, student, ISRO has successfully launched Chandrayaan-1 and placed it into an orbit around the moon, not on the surface, students, on the orbit around the moon. It sent useful information to Earth for about a year. For how much period of time it sent useful information on Earth? About a year, for 1 year. The most discovery made during the mission was the presence of water on the moon surface. See, for 1 year, the information which is being sent on the Earth, that all was, students, that the most important information was that there is a presence of water on the moon. India was the first country to discover this. See, India was the first country who discovered that there is water on the moon surface. Okay. So, students, this was all about the moon mission. Okay. Now we are going to learn about what? We are going to learn about Mars mission. Mars mission we have seen. In Mars mission we have what we have seen, student? Can you see? We all have seen one movie, Mangalyaan, right? Starred by Akshay Kumar and Vidya Balan, right? That movie was based on this Mars mission. So what was that Mars mission? Can you see a Mars planet here? And see the satellite which is revolving around the Mars. Yes, you have in the photograph. This satellite is nothing but a Mangalyaan. This is what Mangalyaan. Now see, next to the moon, the moon mission was much more important till here, but Mars mission was next to impossible for every country because whatever attempt they were doing, it is getting failed and failed every time. For that purpose, student, this mission became very hard to conquer. So next to the moon, the astronomical object near to the Earth is the Mars. What is the next? Because Earth is on the third position, Mars is on the fourth position, right? So for that, which is the nearer one after moon, that is Mars. Many countries send spacecraft to the Mars. Mars mission is difficult and almost half the mission were unsuccessful. See, in many countries such as China, Japan, America, European countries, they all have sent Russia, they all have sent their spacecraft to the Mars, but half of the mission went wrong. It was unsuccessful. It was very difficult to go to the orbit of the Mars. However, ISRO's performance in this mission is remarkable and we all must be proud of it. ISRO has performed a remarkable, he has made on this mission the remarkable, ISRO has performed in this mission is remarkable, student, and we all are so much proud of it that India was the first country to launch his spacecraft in the orbit of the Earth, and it was revolving around the Earth. It was revolving around the Mars. The spacecraft named as what? Mangalyaan, made by ISRO using minimum expenses, very minimum expenses, was launched in November 2013. In November 2013, students, this spacecraft named as Mangalyaan, which was made by ISRO using very minimum expenses, they have launched it in which year? In 2013, in the month of November, and was placed into orbit around the Mars in September 2014. So students, for almost a year, this Mangalyaan was placed into the orbit of the Mars and was giving information about the Mars till September 2014. It obtained very useful information about the surface of the Mars and the atmosphere around it. When he was revolving, this Mangalyaan was revolving around the Mars. So with the help of that, what we have obtained very useful information about what? About the surface of the Mars, about the atmosphere around the Mars. This all we have got. We have all obtained this information with the help of Mangalyaan. I hope this much you all have understood. No objection, no problem is there. Right now, I'm going to the next. See, these are the 3 Indian astronauts which shine the name of India. They have done a remarkable, very remarkable things, which is that they are heroes for most of us. When I was in my child age, I was a huge fan of Kalpana Chawla ma'am, because they have made India proud by what? By giving their performance, by achieving so much height, so much success for India. Now see, the first astronaut was Rakesh Sharma. We all know this first astronaut, the photo of this first astronaut, that he is nothing, he is Rakesh Sharma. He was the first Indian to travel to space. Rakesh Sharma was the first Indian who traveled into a space. He went into the space along with the Russian astronaut under the joint Indo-USSR space program. See, Sir Rakesh Sharma, he went into the space with again which astronauts? Again with 2 Russian astronauts under a joint Indo-USSR space program. Under this program, he stayed in space for how many days, students? For 8 days. How many days he has stayed in the space? For 8 days. Now see, the second astronaut is Kalpana Chawla. Kalpana Chawla obtained her engineering in aeronautics degree. What ma'am Kalpana Chawla has obtained her engineering where? In aeronautics degree from Punjab, and in 1988 obtained her doctorate from University of Colorado. From the University of Colorado, ma'am has obtained his doctor degree, and from Punjab, ma'am has got his engineering in aeronautics. Okay, he has got a degree of engineering in aeronautics from Punjab in 1988. After that, ma'am has obtained his doctorate degree from which university, student? From University of Colorado. She was in space for 336 hours. How much, students? For how much period of time ma'am was there in the space? For 336 hours. During research mission, when she was doing her research work, she was there for 336 hours during his space mission. While returning to the earth, while she was returning to the earth, a sad part came. What? While returning to the earth from the space on 1st February 2003, the Columbia spacecraft exploded. The spacecraft from which these astronauts were traveling, it got what? Exploded. Explosion takes place in the spacecraft and Kalpana vanished. And in this mission, student, when this spacecraft of Columbia was coming back to the Earth on 1st February 2003, an explosion takes place in that spacecraft, and the astronaut, including Kalpana Chawla, which were there in that spacecraft, they died. Now, students, the third astronaut from India, that is Miss Sunita Williams, we traveled to the International Space Station in a space shuttle. See, Sunita Williams has traveled to the International Space Station in which student in space shuttle discovered in 2006. See, she worked for 29 hours outside the space station. See, for 29 hours, Sunita Williams was out of the space station, means she was fully in the space without any, means he was not inside the space station. She was outside of the space station for 29 years and for 29 hours, and she was doing research there. She was doing observation there. She was collecting the sample for how many hours? 29 hours. She created a record by staying for 192 days in the space. Sunita Williams has been stayed in the space for how many days, students? For 192 days. So she has made a record. She has made a highest record of staying in the space for 192 days. I hope you all have understood about the life of Rakesh Sharma, Kalpana Chawla, and Sunita Williams, all these astronauts, right? So, students, till now we have learned about what two missions, that is Moon mission and Mars mission. Now, see, students, there were some missions also which take place to the other planets also, right? So we are going to see this topic into the mission to the other orbits. Now see, many missions have been executed to study other planets also. To study other planets also, students, there were many missions which have been executed, right? Now, in some of these missions, the spacecraft orbited the planet, some landed to the planets, and some just passed near the planet and observed them. See, there were many missions take place to the different planets such as Jupiter, Saturn, right, Uranus, Pluto. In this mission, students, what they have done, they have the mission was the spacecraft has been orbited for some time on that planet. Some has landed on that planet, and some space mission was they have just passed near the planet and observed that planet. Okay. Additionally, spacecraft has been sent to observe the asteroids and the comets. You know, the asteroids and the comets. Asteroids are the big objects which are just in a space. Yeah, they are flow. They are flying from here and there. That are the asteroids and comets. We know when two bigger objects they collide with each other, comets are formed. We all know that. So the comets, and to observe this asteroid and comets, some spacecraft has been sent, and they have successfully collected some dust and stone from the asteroid and brought them back on the earth. After doing the study of this asteroid and comet, students, what the successful things they have done, they have successfully collected what some stones of that asteroid, and also they have collected some dust from that asteroids, and they have get it back on the earth for the research purpose. We are getting very useful information from all this mission. From all these missions, see students, the Mars mission, the Moon mission, the other mission which orbits students, the spacecraft is orbited around the planet. Some are landed on other planets such as Jupiter, Uranus, Saturn. Some just pass near the planet and observe them. Some space missions are what they are just want to observe the asteroid and comet to collect some stone and dust. See, from all these missions, what we gather, students, we gather a very useful information from all this mission, clarifying a concept about the origin and evolution of the solar system. By doing this all space missions, what we do, students, we get all the information about what, and we clarify some concepts such as what, the origin and the evolution of the solar system, from where a solar system get originated, how the evolution of the solar system might be taken place. So with the help of all this study, we have learned about, yes, so this was the origin of a solar system, how was a solar system get originated, how the evolution of a solar system take place. We have understood all these things. See, India and space technology. Now, in this session, what we do, India also has made a remarkable progress in the science and technology for launch vehicles. See, India, we all have know that India has made a remarkable progress in science and technology, and for launching and launch vehicles. Various types of launch vehicles have been developed to put satellite having weight up to 2500 kgs into all three types of orbits. See, we have made various types of launch vehicles have been developed to put satellite of how much of weight up to 2500 kg into all three types of orbit. What are the three types of orbit? That is higher Earth orbit, middle Earth orbit, and lower Earth orbit, right? So which are that launcher vehicle we have made? PSLV and GSLV are the two important launchers. Due to help of these two important launchers of PSLV and GSLV, we have placed the satellite of the weight up to 2500 kg into space. Okay, this much you have understood. Now see, the scientists and technological feats achieved by India in this field have a significant contribution to the national and social development. Now see, this scientific and technology feats which is achieved by India means the development in this, what we have contributed to the national and social development, right? INSAT and GSAT satellite series is actively working in the field of telecommunication. In the field of telecommunication, students, which satellite is being used? INSAT and GSAT. In the functions, in the types of satellite and in the function of satellite, I have made you clear this, that INSAT and GSAT satellite series are actively working for the field of telecommunication, television, broadcasting, and meteorological service, right? Meteorological means for what? For weather forecasting and all this, okay? If some calamities are about to occur, so it gives an alert to us and we get ready for that upcoming calamities. Availability of television, telephone, and internet services all over the nation has been possible due to these satellites only. See, the INSAT and GSAT satellite, which we have launched in an Earth's orbit, due to this only, the television, telephone, the internet services, all which we are using, all the nationwide, it is possible only due to this satellites only. Intosat satellite in this series is used especially in the field of education. There is one satellite known as Intosat. Okay, in this series is useful especially in the field of education. IRS satellite. Now see, IRS satellite is a series is working for the monitoring and management of the natural resources and disaster management. See, IRS satellite, it is a series of satellite working for what, student? For monitoring and management of natural resources and disaster management. If some disaster is about to come, this IRS satellite gives us a signal about that disasters. It gives us a signal of the natural resources, the minerals which are there on the earth. To exactly locate position of any place on the earth's surface in terms of its precise latitude and longitude, the IRNSS satellite series has been established. Okay, students? To exactly locate the position of any place in the earth, we have to exactly locate the position of any place on the earth's surface in terms of what? In terms of its latitude and longitude. Which satellite has been used? IRNSS satellite series has been established for this purpose. Okay, so see, Intosat is for education purpose, IRS is for management of natural resources and disasters, IRNS is to locate on the earth's surface or on prescribed latitude and longitude. INSAT and GSAT for telecommunication, telebroadcasting, and meteorological. And PSLV and GSLV are the launchers for this satellite. This is all our India in space technology, how India has worked in the field of space technology, and how much remarkable projects they have done, successfully they have done, and make India proud for the development, and they have helped in the development of the nation and social development. Okay, students? For now, we are going to see about one scientist, Sir Vikram Sarabhai. Vikram Sarabhai is considered as the father of Indian space program. Sir was what? Vikram Sarabhai is discovered as, see, this is a photograph of Vikram Sarabhai. He is considered as what? Father of Indian space program. His efforts led to the foundation of Physical Research Laboratory, that is PRL, at Ahmedabad. In 1962, Indian government constituted Indian National Committee for Space Research under his chairmanship. Okay, student, in 1962, Indian government has constituted Indian National Committee for Space Mission under his chairmanship, and the first satellite launch center was established at Mumbai in 1963. The launching of India's first satellite, Aryabhatta, into the space was the result of this effort. Okay, student. See, the first satellite which was launched was the what? It was Aryabhatta, which was launched by what? By India under what? Under Sir Vikram Sarabhai. He played an important role in the establishment of Indian Space Research Organization, that is ISRO. Sir has also made a very important role in the establishment of ISRO. Okay, so this is what all about Sir Vikram Sarabhai and his remarkable efforts which he has done for India. Now, space debris and space management. Debris means what? Waste material. We all know. So there are some space debris also, some waste material in the space also, and how it's get and how the management of these debris take place. This all we are going to learn in this point. See, in addition to the artificial satellite, some other objects are also revolving around the Earth. See, artificial satellites are revolving around the Earth, but there are other some objects also which are revolving around the Earth. It includes, what are that some substance? It includes non-functional satellite, part of the launcher detached using launching, and debris generated due to the collision of the satellite with other satellite or any other object in the space. What, student? It consists of non-functional satellite, the satellite which are not in a function. The part of the launcher vehicle which is received during the launching for different stages, the part which is coming by a launcher vehicle that are just revolving in the space only, that are the debris. Again, debris generated due to the collision of the satellite. If one and the other satellite get collide with each other, so the debris which are generated by the collision of the satellites, that are also there. Or any other object in the space, or if any other object, some asteroid, some comet get collide with an satellite, so all that debris are there, all that waste material are lying into an orbit and in a space. Now, according to one estimation made in 2016, there are about 2 crore pieces of length more than 1 centimeter revolving around the Earth. According to an estimation made in 2016, see student, in 2016, according to one estimation, about how much pieces, student, of 1 centimeter? 2 crore pieces of length more than 1 centimeter, they are revolving around the Earth. All this is nothing but a debris in the space. This all is nothing but, student, this is debris in a space. This debris can be harmful to the artificial satellite. They can be harmful to the artificial satellite. It can collide with the satellite or spacecraft and damage them. Sometimes this debris get collide with this artificial satellite and damage them also. See, this is the debris in a space. See the side one. There's a one photograph on. See the debris around the Earth. Satellites are also there, and the debris. See how the Earth is looking like. So the management for this debris is also be taken up. That how to manage this debris. See, this debris is increasing day by day. Soon it will be difficult to launch new spacecraft. Yeah, if there is much more debris in the space, it will become very difficult to launch the new spacecraft. It is therefore very essential to manage the debris. We have to manage this debris. Some studies and experiments are being done with this in the view. Some that soon we will have a solution of this problem, and the future satellite and the spacecraft will not be in a danger anymore. So we are studying and we are doing some experiment that how to manage the debris in a orbit of our Earth, how to manage them, how to control them. Some solutions are been taken up, so it cannot be danger in the future to launch a satellite. So this is the end of our chapter, students. I hope you all have understood all the points in this chapter. So last chapter, chapter number 10 is finished up. Thank you for watching my session, student. Thank you. If anyone has any question, you can raise your hand and ask me. No one has any question? Any doubt? Okay, Harshila ma'am? Ma'am? Harshila ma'am? Okay, students, as in ma'am is not able to get my voice, so I am just ending up this session here only. We will meet on the next day tomorrow, so be prepared for it. Thank you so much.
Yes, ma'am.